Dear students, you are welcome again in this class. And as you remember that we tried to learn use of correlation regression analysis in research papers, how this knowledge is used, and then using Excel for correlation regression analysis. And you have seen how to compute the R of pair data in Excel, correlation coefficient, and then fitting of regression equations. We have completed linear, and today we will learn quadratic, fitting quadratic equation in Excel, and test of significance of equation, whether it is linear or quadratic, then plotting the equation, and finally work out the economics. So I have shown you these papers like in Agronomy Journal, where this relationship has been very, very widely used. Now people use it for representing their data relationship between different variables. And correlation coefficient regression equations are very frequently used. You can use it in your thesis or any research paper also. And for any problem, you can contact me through email. Now we started using Excel, and I have shown you how to install data analysis. Data analysis is compulsory if you want analysis, statistical analysis of any kind in Excel. So I just explained you how to install this analysis tool pack. Hope that you could have succeeded in doing it. And then this is the data. You can see there are number of pairs. There are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pairs are there. 12 pairs of data. But I already told you that minimum pair of data should be 4. And more the merrier, more the better. And these are different variables. It does not matter whether they are dependent or independent. Independent variable. Any of these you can consider dependent or independent. But you need to see the correlation coefficient or relationship between these variables. For this, in one go, in Excel, you can work out or calculate the correlation coefficient.
हेलो सर.
Yes, please.
सर आपने जो होमवर्क दिया था ना वो K2O एंड यील्ड का जो रिलेशन दिया था, डेटा दिया था सर, उसका सर कोरिलेशन कोएफिशिएंट ठीक से नहीं हो रहा है सर. एक्सेल पे सर रिग्रेशन हो रहा है बट कोरिलेशन कोएफिशिएंट सर नहीं आ रहा है.
Okay, I will do it. Actually, today I plan to show you by doing in Excel. So I will take the same example or any other example and try to show you. And actually, I was not knowing that this Excel can be shown online also. That is why I prepared these, this copy pasted the Excel procedures. This, you see, this I was not knowing. Otherwise, I could have shown live is how to do it. But today I will try to show it. I asked my son, and he told me, "Papa, you can do it online." Means Excel can be shown. Let us. I will try. Okay. So I will show you. Don't worry. And then you see, we got this kind of relationship, and you are saying that I am not getting these correlation coefficients for any two variables or more variables. I will show that. Output, and you know how to put a star, 1 star and 2 star. Of course, certain packages or software may directly give you these stars, but this is the limitation of Excel. But if you buy the full program of Excel for statistical analysis, for which we need to pay money, that will give you all sorts of statistical analysis. Thing is that we need to invest the money. This was the homework. Again, you find answers. I think this was the case for you.
Yes, sir.
Okay, you did not get correlation coefficient. Don't worry. Today
no, yes, sir. I have got only 0, 23 and 3.8 between these two variables, but other 4 variables I have not get.
I will show you. So this is how You can do regression analysis in Excel. I explained you the procedure, and today I will demonstrate again. And this is how we interpret the results. Here, this is your ANOVA or F-test, and you can see value of intercept and regression coefficient, and also see the significance. Residual output were also shown to you, and you can see the residuals value is very minimum, very low residuals are there. And then plotting the equation in the graphs or making the graphs, you can go to insert and put a scatter plot, and then select the data and right click and add the trend line. Trend line is here. You can add trend line. On the right extreme, you can see linear polynomial of degree 2, 3, 4, 5. You can play with it. And then tick these two. Display equation on the chart and display R squared value on chart. This is also one exercise I will show you today how to do it. And this is the output. You can see observed data, predicted data, and residuals also. Here you can see correlation coefficient is 0.997 and R square is 0.995. And you can see the residuals. This is difference in observed data and predicted data. Predicted data you get from the line or equation. This is, I think, explained to you, or you can have your own interpretation. And we can have this plotting the line. You can see this is negative correlation between two. You can see on x-axis you have pH. pH is increasing. Remember, in this case, regression analysis, when you have two axes, the data must increase on the right side, and similarly on the y-axis, it must increase on the top side. And here you see one is increasing, other is decreasing. If you increase the pH, the phosphorus is decreasing. Fitting quadratic equation in Excel. So I start from here. It was just recapitulation of the things. Now you go two variables, X and Y, and we are going to do analysis in Excel. I have taught you how to do it manually. And from this, there were several corrected sum of square, capital Z1, capital Z2, means, their means, and then you got several corrected sum of square, small z square, capital Z, Z1 square, Z2 square, summation Z1, Y1, so many parameters were calculated. And then you computed the value of A, B, and C. And then you put those values in the equation, and you fitted the data and you found out the equation. Then you tested it for significance. You used F-test, and then you declared whether it is significant or not. So same thing can be done in Excel also. And you need to have one small trick here. I will tell you what is that trick. So this is your X, 0, 60, 120, 180, and this is your Y, maybe in tons per hectare. Test whether the data shows quadratic relationship or not. Test the significance by regression analysis and plot the equation on the chart. So this is your problem, or this is your objective. Now you can do what you can do here. What is the trick here is that in the first column you have X. In the second column you need to have X square. This is the only trick. X square, you have value 0, 60 into 60, 3600, 120 into 120, you are squaring X 14400, 180, 32400. So this is X squared, and Y value is same. So now you will have two variants of one variable, X and X square. One variant is linear, or you can say, and other variant is non-linear or quadratic. Now, as usual, you can go to the data, this data, and in data you will find data analysis. In data analysis, you can go to regression. You can go to regression. In regression, first of all, you will be asked to insert the input X range or input Y range, whatsoever is. If it is input Y range, you can insert it. or if it is X range, so in X range, you need to select both X as well as X square. So here you can see input Y range. You can minimize this, and select Y. Select Y. Similarly, input X range, minimize it, just click here, it will be minimized, and then select X and X square, select both. So you get data entered here. Then tick this labels. In the first row, you have the labels. So if you tick it, then it will take only your numerical data. Confidence interval is level is 95. Then output range, you can minimize it and just select the place, the space anywhere in the Excel sheet. Just click and select one or two cells. Or you can save output in the new worksheet or new workbook, wherever you want. Then residuals, if you are interested in residuals, you can tick these and then go to OK. So you will have this kind of summary, and one table should also be there, one table. Yeah, this is table. So you can see, first of all, you can see multiple R. Correlation coefficient is 0.99944. And R square, if you square this value, this will be 0.998. And then one thing I want to tell you, that in Excel, sometimes you will get data in this form, 4.44E-06. In Excel, when you have large data, after decimal or before decimal, whatsoever, when you have 10, 12, 13, 14, 15 digits in one data, then Excel may give you this kind of results, 4.44E-06. If it is the case, that means you have to move 6 places left side. You need to move decimal 6 places on the left side. So you can see here, if 4.44E-06 is written in the cell, in the Excel, then it means you have to move this decimal point 6 places. 1, 2, 3, 4, 5, 6. So meaning of this 4.44E-06 is this. Similarly, if you have 2.06E-17, it means 16 0 before 2, before this 2. Or in other words, you need to move this decimal 17 places towards left. And see the next, this was the ANOVA for this quadratic relationship. And regression, you see degree of freedom is 2. It is 2 now, because in regression equation, you have 2 x's. One is x, other is x square. Or otherwise, you can see it is highest value is 2. And then total is 3 because you had 4 pairs of observation. So 4 minus 1 is equal to 3. Then for residual, you can calculate by difference, total minus regression degree of freedom. 3 minus 2, you get 1 for residual. And these are the values of sum of square, 1.8144, and this residual. And then mean square is your variance. Variance for regression, variance for residual. If you divide this by this, you get 453.6. This is the F calculated. And you can compare at 2 and 1 degrees of freedom, the F table value, and you can see the significance. However, here the probability level is given at which it is significant. So you can multiply this value by 100. It is significant at 3.3%. 3.3%, that means it is also significant at 5%, but it is not significant at 1%. And now you see the coefficients in the same, you will get intercept 2.13 and value of B 0.025667, and value of C is your minus 9.4 E-05. That means you need to move this decimal left side 5 places. After 5 places, you put decimal on the left side. So finally, this is your equation, 2.13 plus 0.026x minus 0.000094x square. Now you found out the equation and you have tested it is significant at 5%. That means it is a quadratic equation. The interpretation is
Hello, sir.
yes, please.
Sir, why this is not significant at 1%?
It is not significant because minimum level of probability for its significance is 0.0331. That means it is equivalent to 3.3%. 3.3% it is significant and at higher values. So this is the minimum level of probability at which it will be significant. If you take probability less, then it will not be significant.
Okay, sir.
Yeah, it is very simple. You need to understand something about probability and level of significance. Then you will be able to understand it. But in general, not in general, to be correct, the values you just multiplied by 100, it is 3.31%. And the level of significance which is below than this, the equation will not be significant. But levels higher than 3.31%, the equation will be significant.
So
Now,
how we get to know the equation is quadratic?
pardon?
So how we get to know that the equation is quadratic?
Yeah. Actually, that means if the regression, if the results of F-test are significant, we can say that equation is significant. That means it is a quadratic equation. Actually, I already discussed this issue in one of the email. I sent some details about it. That equation, if it is linear, I told you if it is linear, then the change in the output due to unit change in input is constant. But here it is following almost law of diminishing return. Quadratic relationship indirectly represent law of diminishing return. So you see the rate of change varies in this. Initially it is very slow, then it is very fast, then it slows down, and then it can become negative. If you see the quadratic curve, so the change is not constant. Initially it is fast, then slows down, then it can be negative also. So therefore, we cannot, in this case, if the regression is found out to be significant, or equation is found out to be significant, that means it is a quadratic relationship because rate of change is not same. So this significance test is testing that the rate is not same. If the meaning of this is that rate is not same, therefore it is a quadratic equation. Here it is significant. We have done the significance for significance by F-test for regression. And we thought that it is a quadratic regression. Therefore, we have taken 2 degrees of freedom. So we were exclusively testing whether this data is representing the quadratic relationship or not. So this test, F-test, has proved that this particular equation is significant. That means it is following law of diminishing return, or it is having the variable changes, the difference in change rate is different due to changes in X. I don't know if I succeeded in answering your question. Do you have any?
Yes, sir. Got it.
And I sent you 2-3 mails, and you can read them. They were directly written by me, and you can see for more clarifications. Or is still some doubt, you write to me. Now you see we are plotting this quadratic equation. So as usual, you go to scatter plot, select these points, right click, same way, and then you can go to polynomial of order 2, click on display equation on chart and display R squared. So you'll get this. Now you can have interpretation that this is A, this is B, and this is C. I told you how to get the meaning of this. You need to move decimal 5 places towards left. And now quadratic, you can see, you can write this way also, quadratic relationship between N levels and grain yield of basmati rice. Suppose you have found out this equation, then how to write the title of the equation? So title of the equation, or sorry, title of the graph, you see x-axis you have nitrogen, on y-axis you have suppose yield. So this is relationship between nitrogen rate and yield, grain yield or whatsoever. So you need to name the variables in the. So for writing the title of the curve or title of the graph, you can write like this: quadratic relationship between nitrogen level and grain yield of basmati rice culture, whatever you want. So this is the way to write the title. On x-axis, you need to put proper levels. This I am showing you to if you write in thesis or paper. So this is the way to present your equation. So on x-axis, you can write nitrogen level kg per hectare, or grain yield here, grain yield tons per hectare, and you can write the equation as well as R square. So in this case, particular case, R square was 1. So you can see the line, this white, the line is almost passing through the points. It is almost passing through the point. Therefore, this R square is 1 here. So this is the way to present this, and any point, anything you want to ask here? The MYD is maximum yield dose, optimum economic dose is 151 kg per hectare. Now you see this way you can present in your thesis or paper parameter, formulae and value. So maximum yield dose minus B upon 2C. B you can take from the equation, the value of B and value of C. So in this equation, suppose this is your B, 0.0311, and this is your A, and this is your C, 0.0001 is your C. Now you can calculate the optimum economic dose, Q upon P minus B upon 2C. So here cost of 1 unit of input, price of 1 unit of output, and put the value of BC, you get this. And then response at optimum dose, yield at optimum dose minus yield at control. I explained you. Response in kg per kg, response at optimum dose divided by optimum dose. Then profit. So all these have been discussed in detail. You can go through it and try to understand. Now this is your homework. You can try. Again, homework. You can do it. Just make practice. So what happens many times regression is misused. The knowledge of correlation and regression is misused by people, and they don't go for the proper statistics and just take the data and go for an analysis. So what I have seen many times in case of optimum dose of fertilizer, the equation was linear. The equation was significant only in terms of linearity. It was not a quadratic equation. But what a student did, he by force, he put, he just made quadratic equation. The data was suggesting that it is a linear relationship, but just to calculate the optimum dose of the fertilizer, he or she, he put, he made the quadratic equation. He developed the quadratic equation. Then optimum dose have gone beyond much higher than the tested dose, even than the dose which were tested. It exceeded those doses. For example, here it is 180. So his optimum dose was 220 kg per hectare. It can happen. So first of all, we need to see scatter plot, the trend, and according to that, we can start fitting the equation. First step is to go for linear testing, and second step is to go for higher order testing. So this problem is there. So, and also you know about normal distribution. Normal distribution of the data. Many tests, whether it is chi-square, whether it is Z or F, not F. F test is based upon F distribution. But your T test, I think T test or Z test, there you require, even in many other tests, you require normal distribution of the data. I think in statistics, teacher must be teaching it. What is normal distribution of data? A bell-shaped curve on the left side and right side. So if your data follows normal distribution, then you can go for such kind of testing. Another assumption is, another condition is that your variable should be random, and there are certain conditions. So first of all, we should see those conditions, then we can go for correlation and regression analysis of fitting the equations. So many times you will get abrupt result, and regression is misused. So you can see there is one chapter in Gomez and Gomez book. I think each one of you must be having that book. So in Gomez and Gomez book, there is one chapter, uses and misuses of regression. So there can be proper use and there can be forceful use. The data is not saying use regression here, but by force, okay, I will use it. The conditions or assumptions are not qualified, and even then we use it. So in that cases, you will get wrong results. So here I just want to show you that this is the data. You can do yourself also. 0, 50, 100, 150, and this is Y variable, dependent variable. So now, best fit, what will be the best fit for this data? So see the first case, the graph. Here, Y is equal to 0.0184x into 2.42, and R square is 0.86721. Means R square is also good, 86%. Variability is accounted by this function or by this equation. And you see here also you get about 0.99836 or 99.83% variability is accounted. So here you can see that line is passing through the data. Here the line is not passing through the data, but still it is having good coefficient of determination, good value coefficient of determination. And I have done it, and I found that linear test was significant, means it was a linear equation. Then I also tested the quadratic equation was also significant, means this data shows that it can be a linear relationship or it can be a quadratic relationship, means both the relationships were significant. So it followed both. So why this has happened? Because there may be definitely some problem with the data. It may not be actual data. It may be a fabricated data, not taken in as per statistical procedure. So it can also happen. So you can see, I just compared here. You can see how I am telling that it is significant. You see multiple R, if it was a linear fit. What happened? Linear fit correlation coefficient was 0.93. And here you see when you fit the quadratic, it was higher. Oh, of course, it was higher, 0.999. And you see R square, 0.86, and here it was 0.99 in quadratic. And then you see the significance. Significance here, this is linear, for linear. So it is significant at 0.068. It is significant at 6.8%. So that means it is not significant at 5%. It is not significant at 5%, but here it is significant at 5% because values are less than 5%. If values are less than 5% for the significance of F, then it is significant. If values are more than 0.5, more than 0.05, like in this case, it is non-significant. So here, the linear relationship is non-significant. I was thinking that it is significant, but it is non-significant. But you see, R square and all are good. I think I just placed a wrong example here, but I have one example where both tests are significant. I can share that also. So many times you will encounter this problem, so you need to be very, very careful. Your data should be a random variable and it should be normally distributed. and some other conditions are also there that should be met, then we can go for correlation and regression analysis. This is one example. A field investigation was carried out to record response. You can go through it and practice this example. You are in MSc, and for you, practice of numerical is necessary. So in this case, first you try to understand this example manually. Do it manually. It will take half an hour, 30 minutes. Just do it manually, and then try to do it in Excel. Then you will learn this program or this correlation analysis in a better way. The last thing I want to discuss in today's lecture is that we were dealing with the economics of fertilizer use, or we just tried to find the optimum dose of fertilizer. So overall, in learning this, we have also seen some statistics of correlation and regression analysis, response curve fitting, and so on. Now there could be one more way to find the economic or better or optimum dose of fertilizer. Optimum dose of fertilizer, and this paper is from Dr. Gulab Singh Yadav, who was my first student in MSc, and he is no more. Last year, I think nature has taken him, nature has snatched him from us, and last year I think he died of COVID. This is his paper, and you can see this grain yield, agronomic efficiency, and economic return of zinc used in aromatic rice. So this is one more way to calculate the economics. Suppose these are the treatments, and in every treatment you can see how much zinc was used. So zinc rate kg per hectare. Here 1.3 kg zinc, 1.3, 2.6, 2.6, 3.9. These are different rates of zinc kg per hectare. This is in form of zinc. And then grain yield is also given. Grain yield is also given. Then you can work out agronomic efficiency. Means you can take this, you cannot work out agronomic efficiency for control. 4.25 minus 3.98 and divided by this divided by the rate of fertilizer application. The rate of fertilizer application, 4.25 minus 3.98 divided by 1.3 kg per hectare. And you will get 208 because you need to convert it into kilogram. Convert this 4.25 into kilogram. This also in kilogram. 4.25 minus 3.98 bracket into 1000 you can put, divided by 1.3 you get 208. So same way you can calculate the agronomic efficiency, and economic return you can calculate, because this is because of 1 kg zinc. This is because of 1 kg zinc. You can know the price of 1 kg zinc. It is given here, and you know that this is the output. This is the extra yield because of 1 kg zinc. So you can calculate the economic return rupees per rupee invested. So this is how it can be done, and you can check yourself how it is done. If you have any problem in this, this is the easiest way to compute the economics of the fertilizer. So I think I stop here, and then we will go to the next link, and there we will have discussion and all points. Dear students, you are welcome again, and you see here, and it is the data recorded from a field experiment. Nitrogen rate is the first column. This is the treatment variable which has created the differences in the data. So you have levels like 0, 10, 20, 30, 40, 50, and so on, 110. And these are the observations. You can consider them variable. You can consider them dependent variable or independent variable as per your choice. Plant height, fertile tiller, spike length, spike weight, grains per spike, test weight, grain yield, biological yield, straw yield, and harvest index. This may be data of wheat crop. So you have pair data. This is in pair. This is in pair. This is in pair. So you can make any two pairs, but you can see number of pairs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 pairs in this, and you are going to calculate the correlation coefficient between each other. Here, the doses of nitrogen does not matter anything, because zero dose is across all the parameters. 10 doses across all the parameters. 20 is all across the parameters. So you, for the time being, you need to forget this column. Just forget this column. You are just going to establish the relationship between any two of these variables. Just ignore it now. So how to do this analysis? Just you go to the data. In data, you will find data analysis. Can you see data analysis? Atul? Data analysis. Okay. So I click here, and on click, you can see this correlation. There are many options here. ANOVA single factor, ANOVA two factor, ANOVA two factor, covariance, descriptive statistics. There are many more options here that you can do here. Sampling, T-pair test, T-test or Z-test, regression. Okay, so these are the options in Excel that you can do in the free version of Excel. If you have paid version, then you can have many more options here. So suppose we are interested in correlation. Just select correlation and click OK. I think you may not be able to see it. Can you see this correlation and input range? This is screen.
Yes, sir.
Okay.
Yes, sir.
So in the input range, you just minimize it. Just click it and input your starts from here. Plant height, PHH, and you select all. You select it. And then go to maximize it. Just click here. It will come again. So now your input range is there. Labels in the first row. If labels are there in the first row, labels means PHH, FT, SL. So you click here. It will not use them for analysis, but it will use them for identity. Now comes the output range, where you want to put your results. So output range, minimize it, and just click anywhere here. Just make one click. One click is enough. So the results will come here. Now again maximize it, and then click OK. So you get your results. Can you see the results?
Yes, sir.
Okay, so it is done. It is done. So this is how, and interpretation, you already explained to you how to make interpretations. Now, there was some problem in getting correlation coefficient to some students. So you can see how you can do for this. One is independent variable, other is dependent variable. So here, again, you can go to data analysis, correlation, okay, and then you go to input range. So input range here, minimize it, go to input range. So this is your input range. Select everything here. And then labels in the first row, output range. You want output here. And then click OK. So you get, these are two variables, and you get the correlation coefficient. So Arijit, is it clear now? For two variables, you can do in this way.
Yes, sir.
Any doubt?
No, sir.
No doubt. Okay. So, and also try to do it manually. You can calculate the mean of X, mean of Y, and then calculate the corrected sum of square, like small x, x minus x bar, y minus y bar, square them and put up in the formula and calculate the correlation coefficient. Summation xy upon under root summation x square y square. You will get correlation coefficient, and here also. So it's very simple. Now suppose you want to fit a linear equation in this. You want to fit linear equation. Assume that you want. So what you require to do, go to the data, go to data analysis and select regression. This time you need to select regression. Select the regression, okay. Now you see input Y range. Input Y range is your dependent variable. Minimize it, go to this, select the Y 13, 13.8 and up to 14.8. You select this and again maximize it and then go to input X range. This is independent variable. So here you select X 0, 20, 40, 60. Maximize it. And now labels you can put, because in the first row you have X and Y. Confidence interval is already set, means your probability level is level of significance is 5%. Output range, minimize it. And if you want your output here, just click here. And it is ready to be okayed. Or if you want residuals, you can click residual plot, or standardized residual, anything you like, you can click. And then click OK. So you get the result. And also the residual plot. This is the distribution of the residuals. Now you see, this is correlation coefficient, this one. So it is the same what you did from correlation analysis. From correlation analysis, you found this correlation coefficient, and same is here also by regression analysis. The results are not going to change. And this is R square, 0.98. Now you see this is the analysis. Degree of freedom for regression, it is linear, therefore it is 1. Residual, it is 2, and total is 3. Because total is n minus 1, 4 minus 1 is 3. And regression, it is linear regression, only x power 1 is there. Therefore, it is 1. And 3 minus 1 is equal to 2. Now, sum of square and then mean square, f calculated, and then significance. Multiply by 100, you will get 0.822%. Means it is significant at 0.822% or high level of significance, but non-significant at 0.08. At the level which are lower than this. At the level which are lower than this. So you can see the intercept is A, 13.08. This is the value of A. And you get value of B, 0.029 is the value of B. I just missed it. 0.00, you multiply it by 100. So it is significant at 0.82%. Then it is also significant at 1%, or levels which are higher than this. It is significant at that. Levels which are lower than this, it is non-significant at that level. Now you see intercept value of A is given here. Value of B is also given here. So this is value of B, this is value of A. And you can also see the significance of B, the regression coefficient. Significance of B. The P value is here. The P value is here. That means it is a linear relationship. It is proved that at 5%, 1%, it is linear relationship. The rate of change is constant. Now you see, this is predicted Y. Predicted Y means in place of X, you put this 0, 20, 40, 60, 1 by 1, and you will get the predicted value for 0, for 20, 40, and 60. For 60, it is 14.88. So if you subtract this from this, you take this, copy, you can paste it here, and this is your predicted value. Copy it, paste it here, and take the difference. This minus this. So you get predicted value. Very easy. Observed minus predicted, you get residuals. So same residuals are here, you can see. So they are very nominal value, very small value. Means most of the data has been accounted for. And now after this, now you have seen correlation coefficient, how to work it out in Excel. Then you have seen the making the testing the significance of the quadratic equation and fitting the equation also. So because fitting means you get value of A and B here, and you have also tested the significance. The next step is representing by a graph or plotting the equation, how to plot this equation. So you have this data. This is the data. Take it down, paste it again. Now I am showing you how to plot it. Go to insert and click the plot, this scatter plot. Just go to insert and click the scatter plot. Select the first one. Okay. It has come. Can you see it? These points are very small. Can you see the points here? This point, this point.
Yes, sir.
We just scatter plot, and then on x-axis you can see there are different levels, 0, 10, 20, 30, 40, 60. You can manipulate it. You can change this also. You can change this interval. You can change the minimum value. You can start with the 0, 20, 40, anything you can do. You can manipulate this. Similarly, you can manipulate this also. You can change the interval also. Suppose here 12.8 to 13. So here the gap is 4.2. So you can make it 0.4, 0.8 simply by changing the alteration or doing alterations in the y-axis. Similarly, you can do in x-axis. So now you select the points, click right, and you will find add trend line. Click it, and on the right side, you will find this. So you are fitting the linear, just click on linear. If you are interested to put polynomial, it starts with 2. You can select this, and you can, here you are selecting suppose linear. And then click on the display equation on the chart and display R squared. So you get this, and now you can close it. So you can see this is the line you have plotted, and this is equation, same equation, what you see above. You can see here. You get 13.08 here, intercept. It is 13.08, and B was 0.029. So here also, B is 0.029. And R square is 0.983. So you will see R square is also 0.983. So you get same. You got residual analysis, everything is complete about this. So anything, any doubt you want to clear about this correlation, regression analysis? Any point? Is it clear? Okay, next. This is again the same, you can practice it. I think this is linear relationship, but it is in negative sense. So I'm not showing you the regression and correlation analysis, but just I can show you how to plot it. You can go straight away here, make this. It will not come anything. You just select it, select and go to insert, and then click on scatter, and it will come like this. So you see, it is showing you some linear trend, but it is in negative. It is negative. One is increasing, other is decreasing. Okay, no problem. Let us and then select it, right click, add trend line. It is linear. It is looking, it is almost linear. So you need not to worry about it. Just go to linear, display equation on chart, this. And then it is over. Now you see R square is very high, 0.995. It is good. And this is the equation. This is your B and this is your C. The sign is minus. It is not actually, the 5 is not 5 less than 0. It is actually just a direction of change. So you should take absolute value, even if your correlation correlation coefficient is negative. Correlation coefficient is negative. Just consider the absolute value. This is just direction of change. And one more point I want to tell you here, that this graph is not looking good. It is just in this side, and most of the part it is blank. You see, most of the part is blank. So we are unnecessarily using extra space. This space is useless. So we can start with the point, you can see 6. We can start with the point 6 on x-axis. And x-axis you have pH. So even we can start at 6 point something. So let us start with 6. So we can start it at 6. You can see, select this axis and then format axis. Right click, format axis, and you can, the minimum is 0. So you change this to 6. Okay, and then enter. So now you see the look is better. You see, data is same, but look is better. And also, you can see that we are wasting space here also. Some space is wasted. So let us start from 6.1. So just select it and format axis. You can start from 6.1 or 6.2. Okay, now it is fine. Now similarly, your this y-axis, this much of space, you see, this much of space is wasting, we are wasting. And graph is not looking very attractive and catchy. So what we can do, we can remove this much of space. We can start at 5.8 because you see the last point is at 6. So we can start at 5.8. Just format axis and go to minimum is 5.8 and click enter. Now you see it looks better. So this is what I suggest you. If you find like that, you remove the extra spaces by changing the start. Instead of 0, you can start with any other point here. So no problem. So this is the way you can put it. You can do the rest of the things here. Any point, anything you want to discuss here? Any point? No issue. The last thing, now we will deal with, or you can calculate you can do the regression analysis also here. Just I'll do it in a minute. Go to data analysis, go to regression, okay. Now you select Y range, input Y range. You can select, this is your Y range. And then input X range, minimize it. This is your X. Then again, maximize it. Labels in the first row. And then output range, where you want to see your results. So you can go down, little down, select here. And then residuals, residual plots, etc. Click OK. You get the results. You can see the level of significance. You can see that coefficient intercept is 48.7 and this B regression coefficient is -5. 48.7 and -5. You can see here, same thing, 48.7 -5. And you can see rest of the statistics here. Very easy, much easy, and I hope that you will be able to do it. Now we go to quadratic relationship. So here you need to do one trick here and cut it, go to the next paste, and here you need to take one column, that is x square. Assume this is x square. So now this will be 0. And 60 into 60 means how much? 60 into 60.
3600.
3600. Okay. And 120 into 120?
14400.
14400.
And the last one?
32400.
Or otherwise, I think you can do it like this. 180 into 180. I think. Is it correct? ठीक है क्या?
Yes, sir. Yes, sir.
Okay. So now you can go for regression analysis. These are data. Go to data analysis, select regression. Okay. Now input y range. Y is your dependent variable. So this is your y. Select the y 2.1, 3.4 up to 3.7. Input range, minimize it. Select x and x square both. Okay. And output labels in the first row. Okay. Output range, minimize it and click it here. And then again, okay. You want, you can have residuals. And then click OK. So you got this analysis done. And you can see the interpretation here. Correlation coefficient R square, regression is 2 here. It was your quadratic, therefore degree of freedom is 2. Total are 4 minus 1, 3, and 1 for residual. Sum of square, mean square. Okay. And you get predicted values also and residuals. You know how to get these residuals. I will not repeat this time. I assume that you must have understood it. And see the significance here. It is significant at 3.3, 1% level of significance or higher level of significance. So I think the last thing is that you can plot it also. You can plot it like this. This time you take only 2, copy or paste, remove this. Why it has come? This sign, there is no value here. What is the reason? Here,
Because of reference of formulas.
because of
Reference. Excel consider reference of formulas. You need to copy and paste the values only, not the whole thing. Otherwise, it just copy the cell formula also.
okay. Thank you. Let me try. Okay, but it can be both way also. If we reduce the size of the font, just I reduce the size of the font and it is visible. But if I increase the size of the font, again it is visible. Anyway, now you see I can remove this x square and then just cut it, paste here. Now it is xy and you can plot this equation. Go to insert and this, and now you select the data. I can increase the size of this. Okay, now it's easier. Add trend line, and then you go to polynomial. Okay, So this is done. Okay, here title, you can write relationship between so and so. Whatsoever it is, you can see, and this is fine. But one thing you can do, now you see it is looking somewhat flat. Of course, it is 100% quadratic equation, but it is not looking very catchy to our eyes. In the world of today, you need to make the things attractive also. So what you can do, see here, this much of space is wasted space, this much. So you can start with 2 here. Instead of 0, you can start with 2 here. So select this axis, go to format axis, right clicking, and minimum you can set here 1.8 or 2 also. 2. Now you see the same figure, same thing, but it is giving you better look. And also you can change this one also. This one, the largest value is 180, but here it is using 200. So instead of 200, you can reduce the maximum. Maximum you can exactly make 180. Why to use it? Now you see, it is looking differently. And you can just do it like this. You can do it more like this. Now you see, it is looking much better than the spreading one. The data is same, everything is same, only your presentation has changed. So this finishes this part. If you have any doubt, anything in your mind, you can ask about it. Should I close it, or you want to know anything more from the Excel file? Should I unshare it, or you want me to do something more that you could not understand? You're keeping mum, nobody to answer. Okay. So then I can close it. I can stop share. And now, if you have any question, you can ask. Otherwise, you can have a nice day. Ankit,
Yes, sir.
any question?
No, sir.
So last thing today is that I have just exposed you to the topic. I tried to get some interest developed in you so that you can try to learn more. Practice few examples, and that is all I can say. Thank you very much. And tomorrow I will start very interesting topic, that is organic farming. So it is over, and the students who have cereal crops can fix the time. I will start teaching them rice. So how is there anybody among you who has offered that course, agronomy of cereals and pulses, major cereals and pulses? Any one of you? Hello? Nobody is there in the cereal?
No, sir.
हैं? बोलो यार, क्यों शर्माते हो? Anyway, give me your attendance. I'll come to the students through email. The students who are in cereal crops, I will come to them through email, and we will decide the class time. So now we can see each other. At least today was some holiday, I think. So thank you very much. Despite holiday, you attended the class. I am thankful to you that you are learning something. So thank you very much, my dear student, and bye-bye.
Thank you, sir. Thank you, sir.
Bye. Have a nice day. Have a
Thank you, sir.
Okay.
sir.
Bye. Bye.